So Friday we were discussing parabolas, and I told you we'd do example 7 when we got back on Monday. So when you're solving an equation for a parabola, just like I told you on Friday, you're solving for the variable that's not squared. So we're going to be solving this for y. So I want to get the y to one side and both of the x's to the other side. So I'm going to leave these two x's on the left, and I'm going to move this negative 4y to the right. So I have x squared plus 4x equals a positive 4y. Now what I'm going to do is I'm going to change this left side so that it's going to be something squared. So in order to do that, we're going to do something you learned in Algebra 1, Algebra 2. It's called completing the square. So anytime you complete the square, when I teach it, I always tell my kids to write the x squared, the x's, so the first term and the middle term, plus some last term, which we're going to figure out in a minute. To get this term over here, you're going to take half of the middle term and then square it. So what's half of 4? Half of 4 is 2, and 2 squared is 4. But whatever I add to the left side, I have to also add to the right. By doing this, we're completing a perfect square. And now I can rewrite this as what factors of 4 add up to 4? Well, that's positive 2 and positive 2. So now I've completed the square. I'm going to move the 4 out of these. So I'm going to factor out a 4. And then all I have left to do is divide by 4 and subtract 1. So I'm going to have x plus 2 squared over 4 minus 1 equals y. So now I have it in graphing form. I can tell because it's a y equals parabola, it's either going to open up or down. Because it's a positive, it's going to open up. My vertex is going to be at negative 2, negative 1. Always the opposite. It's going to open up. So if I go plot negative 2, negative 1, 1, 2, negative 1. Remember that your a is always equal to 4, your denominator is always 4a. So if 4a equals 4, a equals 1. Remember it's going to open up. So if it opens up and I go up 1, there's my focus. And if I go down 1, there's my directrix at y equals negative 2. What else do they want? The focus, the vertex, and the directions. Okay, that's all they wanted. So again, sometimes you're going to have to do what we call complete the square. Anytime you have an x squared and an x, or a y squared and a y, and you're trying to solve for the variable not squared. And there's one just like this in your homework that we'll look at in a second. So now let's look at the homework. So this is worksheet 9-2. And I did take a few problems off. So I took off number 27. I took off number 35. I also took off 43 and 45. On the back, I took off quite a few. In fact, the only one we have to do on the back is number 59. So I'm going to go through a few in each section just to make sure you understand how to do it. So in this first section, we're just playing the matching game. So in this first section, you want to solve for the variable not squared. Sometimes it's going to be x, and sometimes it's going to be y. So if we look at problem A, and I said, what variable is not squared? You tell me x, so we're going to solve for the x. So when I solve this, I get x equals y squared over 4. Because it's an x squared and because it's positive, I know it's going to open to the right. So number 13 opens to the right, and so does number 16. But because there's no parentheses, I know the vertex is at 0, 0. So this is the vertex at 0, 0 that opens to the right. Now I'm going to go look at h. So we're going to start off the same way. I'm going to solve for the variable not squared. Y is not squared. So I'm going to divide both sides by negative 4 first. And then after I divide by negative 4, I'm going to move this 1 to the other side. So we have x plus 1 squared divided by negative 4. And if I move that to the other side, I get a minus 1. So I have a y equals equation, so it's either going to open up or it's going to open down. Because there's a negative out here, it's going to open down. So it's either going to be 15 or it's going to be 14. because there are parentheses right here, I know that my vertex is going to be at -1, -1, which is number 15. Okay, now on this section, they want me to find the equation. They want me to find the 2 points that make up the LR. Remember, the LR is always 2A. And they also want me to graph it. And I told you when you graph it, I want to see a vertex, a focus, and a directrix. So on number 19, they tell me the vertex is at 0, 0. I'm going to label it. And my focus is at 4, 0. The distance from the vertex to the focus is always going to give me my A. So I can tell in this problem the distance from 0, 0 to 4, 0 is 4. So my A is equal to 4. Okay, that also, because my vertex is here, my focus is to the right, it tells me that my parabola is going to open right, because the focus will always be inside the parabola. Outside the parabola, a distance of A, 1, 2, 3, 4, and the opposite direction will be my directrix. So this is my directrix. That's a vertical line, and the equation is x equals -4. So I've graphed my focus, I graphed my vertex, I graphed the directrix. I still need to write the equation and find the LR. So because this parabola opens to the right, it'll be an x equals equation. Because the vertex is at 0, 0, I don't need any parentheses. I just put y squared divided by 4 times a. Well, my 4 times 4 is 16. Another way to write the same equation is x equals 1 over 16 y squared. These mean the exact same thing. The last thing I have to do is find the LR. To find the LR, so it's always twice the A. So if A is 4, 2A is 8. And it's always going to be that distance, 2A, from the focus. So from the focus, I have to land on the parabola. I'm going to go up 8. That's one of my LRs, and that point right there would be 4, 8. And I'm going to go down 8 and also lie on there. So that's 4, -8. So my two LRs are 4, 8, and 4, -8. And that's how you do this whole section here. So you're going to do the same thing for 21, 23, 25, and 29. Same thing again on 31 and 33. That doesn't change. On 37 through 47, all they want me to find is the vertex, the focus, the directrix, and then graph it. They don't ask me to find the LRs at all. And so what I like to do is I like to find these right on the graph and just label them. So just like when we did 11 through 18, we have to solve these for whatever variable is not squared. So the variable not squared here is y. So if I solve for y, I divide both sides by 4, and I get y equals x squared over 4. So because it's a y equals, and there's no parentheses, I know it's going to open up from 0, 0. So I know I'm going to have one like this because it says y and because it's positive. There's no parentheses, so it's 0, 0. In order to graph the focus and the directrix, I have to know the a. Remember, your denominator is always 4a. So 4a equals 4, so a equals 1. So I'm going to go 1 above to get the focus. So the focus is 0, 1, and I'm going to go 1 below to get the directrix. So the directrix is y equals -1. And you're going to do that same process for all the problems. Let's go look at 47, because 47 is kind of like the one that I did in example 7. So we're solving for the variable not squared. The variable not squared is x. So I'm going to move the x and the 4 to the other side. So if I'm going to move this over here, I get -4x minus 4. And I'm going to complete the square. So remember, I said when you complete the square, you leave a little space over here. And in order to figure out what goes in this blank, you take half of this number and square it. So half of -4 is -2, and -2 squared is 4. If I add 4 to this side, I have to add 4 to this side. Okay, so now we're going to square it. So what factors of 4 add up to -4? -2 and -2. Over here on the right-hand side, these two 4's canceled. and I'm left with negative 4x. So all I have to do now is divide by negative 4. So we have x equals y minus 2 squared over a negative 4. Okay, so if I were going to graph this, because it's an x equals and it's negative, I know it's going to open to the left. There's nothing out here, but I do have in parentheses a y with a minus 2. So my x coordinate is going to be 0, but I'm going to go up 2. So my vertex is at 0, 2. I'm going to open left because it's negative. Your denominator is equal to 4a, so 4a, so it's 1. So my focus always has to be inside, so I'm going to go inside 1. So that point right there would be negative 1, positive 2. I'm going to go to the right 1. So my directrix is x equals negative 1. So vertex, focus, directrix. Everything's there. On the back, I got rid of all of these, so we don't have to worry about those. Down here in this section, they want you to write the equation of that parabola. To write the equation of the parabola, the first thing I'm going to notice is that it opens up, so it's going to start off with a y equals. And because it opens up, it's going to be a positive. I also know that the vertex is at 0, 1, so I'm going to have an x squared over whatever 4 times a is plus 1. I can't tell what a is because they didn't give me the focus, they didn't give me the directrix, and they didn't give me the LRs. So this is kind of like example 5 that we did in our notes where I have to go solve for a. So I'm going to take the point that they gave me, which was 2, 2, and I'm going to plug in. So for y, I'm going to plug in for 2, and for x, I'm going to plug in 2. And I'm going to go solve for a. Well, the first thing I'm going to do is I'm going to subtract 1. So 2 take away 1 is 1. 2 squared is 4 over 4a. Okay? So now I'm going to multiply both sides by 4a. And I get 4a equals 4. So a equals 1. So if a equals 1, then my equation is just y equals x squared over 4 plus 1. Okay, I hope that helps you with your homework.